question 9. So for part A, we've got to find the area of the sector FEA. Okay, so we're going to use the formula half r squared theta. Obviously the radius is x, so it's going to be half x squared. Now what is this angle here? Well, we're told that this over here is an equilateral triangle, so obviously each angle is 60 degrees, or in other words pi over 3. So given that's pi over 3 and the angles on a straight line add up to 180, which is pi, this angle here must be pi take away a third pi, which is 2/3 pi. So that's where that angle's come from. So popping that into the area of a sector, we get this. Now for part B, we're being asked to show this, given that the total area of the enclosure is 1,000. Well, the area of the enclosure comprises a triangle, the sector, and a rectangle. So we know the area of a triangle is half AB sin C, so that's half times x times sin pi over 3. The area of the sector we've just worked out up here in part A, and then the area of the triangle is just base times height. Well, the base is an x and an x, so 2x times y. Now we're told that this all together equals 1,000. The total area is 1,000, so that equals 1,000. Rearranging this, making 2xy the subject, we get this. Then dividing through by 2x, we get y equaling this. And then by tidying up and factorising, we end up with what we had to show. Now that's a lot of work for 3 marks. I think as long as you can get a long way into that, if you don't quite get through all the tidying up, that's not the end of the world. Now for part C, we've now got to show that the perimeter of the enclosure is given by this. So the perimeter, so running all the way around the outside of the shape, we've got a y here, a 2x here, a y here, an x here, and then the length of the arc. Remember, the length of an arc is r theta, so that's our radius, which is x, times that angle, which is 2 pi over 3. So tidying that up, we get the perimeter being this. Now you see that what we're aiming for only includes x's, it doesn't include y. So at this point we've got to substitute into the perimeter what y is. We know that from part B. So we're substituting into here, we're replacing that y with what we were given in part B. Then multiplying out and factorising a bit, again we end up with what we had to show. Now again, I think that's a lot of work for 3 marks, so I think if you get most of the way through, so you're sort of picking up 2 marks for B and 2 marks for C, that's fine, because comparatively D is pretty straightforward and there's a full 5 marks going for that. So you must make sure you get through onto question D and E and you don't run out of time faffing around with B and C. Okay, so part D, we've got to use calculus to find the minimum value of P, so we've got to differentiate this. So first of all, rearrange it into a form that we can differentiate it. So I've sort of taken the x upstairs, so that's 1,000 x to the minus 1, and I've basically just got this times x as for the second term. Now, so differentiating, how do we differentiate? We multiply by the current power, reduce the power by 1. So that becomes minus 1,000 x to the minus 2, and obviously when we differentiate a constant times x, we just get the constant. So that's this bit, and we're trying to find the minimum value, so we set the differential to being equal to 0. So then adding, so from that, adding this to both sides and taking the x to the minus 2 downstairs, we get this here. I've then reciprocated both sides, so just flip both of them over to get this here. So then I've times by 1,000 and square rooted thereof to give me x being 16.639 ... Now I've got to find the minimum value of P, not the minimum value of x. So I take that value of x that I've got and I substitute it into the P formula here, and that gives me P being 120.236 ... or 120 meters to the nearest meter. Now for part E, I've got to justify by further differentiation that the P is a minimum, so I take the second differential. So I go back up here to my dpdx and I further differentiate this. So I multiply by the current power, which is minus 2, so that gives me plus 2000, and I take away 1 from the power, so it's no longer x to the minus 2, it's x to the minus 3. And then taking that downstairs gives me 2000 over x cubed. When I differentiate this constant again, it disappears. So my d2p dx squared equals 2000 over x cubed. So obviously when I substitute in my value for x, which is 16, I've got 2000 divided by a positive number cubed. So positive divided by positive is greater than 0, and that justifies it being a minimum.